Make a nice big circle. Population. So what's the population? It could be everybody in this building, everybody at St. John's University, everybody in New York City, everybody in the country, everybody in the world. It could be all the trees in a forest, all the insects on a certain tree. Population is whatever you care to study is the population. Let's make population St. John's University. Now, usually you care about a particular characteristic of the population. What is the average weight? What is the average height? What is the average income? The average number of pets? The average number of children? The average number of credits that you're taking? The average of something. It doesn't have to be an average, but average is probably by far the most important parameter that we care about. So what characteristic do we care about? Let's call it age. But of course, we could have asked something, what's the average number of children in the house, how many pets you have, but we'll call the average age. And somebody starts up a research project trying to come up with this number. Now, the first thing you might want to do is go to the computer. You say, well, everybody, when they register, and by the way, the population size, let's say, is 20,000. So I'm using capital N for the population and small n for the sample. But when you register, you type in your birth date, probably, your age, or something like that. So you could theoretically go to the database and get the answer. But let's say the question was, what is the average number of children in your family? Or how many pets you have in the house? I'm pretty sure when you register, nobody asks you to put down how many pets you have in the house. So you can't get it from the database. So the next best thing is to contact all 20,000 people at St. John's University, come up with ask them the question, send them an email or a survey of some type, with a self-addressed envelope. And if everybody answers the question, what's your age? People say 21, 23, 21, 20, 19, 24. You simply take an average of all these numbers, and the average of those numbers will turn out to be, of all 20,000 people divided by 20,000, the average will be equal to the average, and you're finished. And you get the perfect answer. You don't need anything fancy beyond 5th grade average. The problem with that approach is, anybody want to tell me what's the problem with that approach to getting the answer? Again, our goal in this chapter is to come up with what's the average of a particular parameter, a particular characteristic. What's the problem with doing what I just said? Yes, David? Yeah, not take a long time. Let's say you send out 20,000 emails. How many people are going to answer the question? Say, I'm working for the president of the college. I'm doing a survey. We need to have your average, your age. So somebody's going to say, okay, I'm 21. Hit reply. How many people are going to answer the question out of 20,000? Small number, maybe a couple of thousand, 3,000, 5,000, 2,000, who knows, but not everybody. Then you're going to send them a second email, a third email, then you send them a letter, then you go to their house, you hire a private investigator, go to their house, knock on the door, then you call them up, you have the president of the college calling them up, If you really try really, 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 really hard, you could get almost all 20,000 people. But what's it going to cost you? $1 million? Think about it. It costs like $1 million probably. At least $5. Well, a lot of money. So obviously that approach, while it's theoretically doable, is not really practical. And therefore, if we still want the answers to the question, I would ask the class to give me this answer, but it's sort of obvious, and I'm not going to break up the flow of the video. The answer is you would take a sample of people. Hopefully the sample is representative of all 20,000 people. So when you take a sample, there are two questions you have to answer. What should be the size of the sample? Which should be 100 people, 500 people, 200 people, 30 people, 1,000 people out of 20,000. The size of the sample is a very important question, which we're not going to answer right now. There are formulas for it that's going to really require us to go to chapter 9 or so to really understand better. But right now we'll be told the sample is, let's say, 100. And then the question is, how do you pick those 100 people? You just put everybody's name in a hat and pull them out at random? That will work. You want the sample to be representative of the 20,000 people. A similar number of freshmen, let's say a quarter of the population of the St. John's is freshmen, so about a quarter of this sample should be freshmen. I mean, we'd like it to be, let's say, 55% are females, we like 55% females. 5% Jewish or 5% Jewish. I mean, you want everything should correspond. Now, one way to do that is by putting everybody at random. But there are a lot of complications how to get a sample, and we're not going to get into that either right now. But you realize that's a very practical, difficult problem. Yes? What did I just say a minute ago? I just said that it's a difficult problem that we're going to learn about in Chapter 9. It's an excellent question. I want you to ask me that kind of question. But I'm saying, did you hear me say that a second ago? That I said that we're going to talk about that in Chapter 9. And surprisingly, the size of the sample, one thing a lot of people think, I'll give you a little bit of a heads up, a lot of people think the size of the sample has to be like a fraction of the population. If you have 20,000 people, so you got like 1,000 people or whatever. If you're sampling 20 million people, then you got to take a larger population. That turns out to be, while it's sort of intuitive, it turns out to be wrong. That the size of the sample has very little, if nothing, to do with the size of the population. We'll learn about the population. So we're going to spend a lot of time answering that question. Again, since you asked the question, and I'm sorry for pushing it aside, depends upon how accurate you want to be, how much time you have. If you have, if each person costs you 1 penny, so take 10,000 people. If each person costs you $100, and you can't afford to take them, it depends upon the cost of these things. Depends upon the variation. If all the numbers in your sample are very similar, then a small sample would work. If the numbers are all over the place, then you need a large sample. So a lot of things go into that formula, but we'll see a lot of it here as well. So we take a bunch of people in the sample. What do you think the next thing is going to be to calculate? Raise your hand if you want to answer. What's the next thing after we take this? So we have the problem. We picked 100 people at random, and easier said than done. So we have 100 numbers now. So now we have 100 numbers. 100 numbers. So what do you do with those 100 numbers? What do you think the next logical thing to do? Yes, Laura. You get the average. So the next thing is to calculate the average of 100 numbers. Let's say it came out to 20.5, to be concrete about it. 20.5. Okay. So again, I owe you one of these, and pass it back to Laura, please. Or self-service. Okay. So 20. What do you do next? Have we solved the problem? Can you go back to the president? Let's say the president hired you and gave you some money to do this research. And you go back to him and you say, Father Harrington, the answer to your question is the average age on campus is 20.5. Would that be a practical answer? Yes. Would it be the right answer? No. Why is it wrong? Yes. And in fact, if you took another 100 people, let's say he said he didn't trust you, he gave another $5,000 to somebody else to do the same survey without you knowing it, you think the next person taking another different 100 people come out to 20.5 also? He might, but he might not. So the point is, just because you came out with 20.5 doesn't mean that that's the answer to the question. Coming up with a single number is called a point estimate, just a single number along the number line. What we really want to say, to make it more practical, I'm going to pass it back to Tiffany, please. Yes, Julie. Say again? Well, again, I mean, we're taking 20,000 people on graduate, undergraduate, pharmacy school. 100 people, a few people should be included in the graduate school. I mean, we're just picking people out of a hat, so everybody has an equal chance of being chosen. Okay, so that's a very good insight. I think you're leading to a very good question. That's going to make the variability larger. Instead of everybody being between 18 and 22, you're going to get between 18 and 62. So that's going to throw off some of our calculations. So what does that mean? It means we're not going to be as precise as we could have been. So I mean, that's see, Mike. So if the question is, what is the average age of the undergraduates? You're probably going to get a better answer, but we're still trying to answer the average age of the whole campus. So without having, so what's the number that we also, what we've been saying in the last 2 or 3 questions that I got sort of going in that direction, what's another key number here that we really should know about or get or use to solve the problem more comprehensively? What's the other number that we're looking for? Based on your question and maybe your point, what's the other number that I should put down on the board before we go further? In other words, what number measures? Remember we said if everybody is similar to each other, then we can say, I'm pretty sure the answer is pretty close to 20.5. But if people are all like people 99 years old and 3 years old and 25 years old, they're all over the place, are you really comfortable with saying the answer is pretty? No. It could be a couple of numbers may have thrown off your answer, especially if your sample size is small. So what's that number that we're talking about that basically combines all that concept? Yes. The variation, the range or the variance or the standard deviation. So we need to know the sigma, which is the variation of the population that we're drawing numbers from, just like we needed the sigma for these other problems that we had in all the other chapter 6, chapter 7, and now in chapter 8 and chapter 9 and we need sigma. So let's make up a number. Again, I'm just making it up, 2. Now how would you know that? Well, the only way to know the sigma is by having the whole population in front of you. But if you had the whole population in front of you to calculate the sigma of the population, which is what the Greek letter is, then we might as well calculate the average age of the whole population. So having the